Hi guys, myself Nitish Jadhav. In this topic, we are going to deal with the quarks, mainly up-down strange quark. Now, the main part that we are dealing is the nature, properties, its behavior, mass, charge, spin, etc. Coming to the part of introduction. Quarks are defined as a number of subatomic particles carrying a fractional electric charge postulated as building blocks of hadrons. Hadrons means quarks or antiquarks which are believed to be isolated and they are only ever found in combination called hadrons. There are three types of hadrons: mesons, baryons, and antibaryons. Mesons are the quark-antiquark pair. Baryons are the combination of three quarks. Antibaryons are the combination of the three antiquarks. Now, the quarks are classified into six types. First one is up quark, second is down quark, third one is strange quark, fourth one is charm quark, fifth one is bottom quark, and the sixth one is a top quark. Now, based on the generation also, they have the three types: first generation, second generation, and third generation. The first generation, they have the up quark and the down quark. In the second generation, they have the charm quark and the strange quark. In the third generation, they have the top quark and the bottom quark. Now, the heavier quark rapidly changes into a up and down quark. This is due to they are generally stable and also the most common in the universe, whereas the strange, charm, bottom, and the top quarks are only produced when the collision is the high energy. Nature, properties, and its behavior. This table mainly shows the additive quantum numbers of the quarks, whereas a small letter d represents the down quark, U for up quark, S for strange quark, C for charm quark, B for bottom quark, and T for top quark. And the properties like an electric charges, isospin along Z components, strangeness, charm, bottomness, and the topness. And the values have been listed up. Moving on to the next slide. Up quark. Up quark is in a first generation quark. Interaction that are shown by is in a strong, weak electromagnetic force and the gravity. Symbol used is U. Antiparticle is in a U dash. Mass it has the 2.2 plus or minus 0.5 MeV square. When it decays into a down quark or electron neutrino. Electric charge is in a plus 2 by 3e. Spin is 1 by 2. This figure mainly shows the up quark and the down quark present in the neutron and the proton respectively. Moving on to the down quark, it is also in a first generation quark. Interaction that is shown is in a strong weak electromagnetic force and the gravity. Symbol here is D. Antiparticle is in a D dash. Mass is 4.7 plus or minus 0.4 MeV by C square. When it decays into an up quark or electron antineutrino. Electric charge is minus 1 by 3e and the spin is 1 by 2. Coming to the strange quark, it is in a second generation quark and the interaction is strong weak electromagnetic force and the gravity. Symbol is S. Antiparticle is an S dash and the mass is 95 plus 9 minus 3 MeV by C square. When it decays into an up quark. Electric charge is minus 1 by 3e and the spin is 1 by 2. Conclusion part. It is very successful in enabling the understanding many qualitative and the quantitative property features of an hadron's physics. It is true that since the quark model was introduced, the number of quarks necessary to reduce are the hadrons. Without the quark, it would be much more difficult to make a connection between the weak interaction of an hadrons and the leptons. Further, turning it to a strong interaction, we have the hope that quantum chromodynamics will prove the successful theory of a quark interaction, whereas quantum chromodynamics means a quantum field theory in which strong interaction is described in terms of an interaction between the quarks intermediate by gluons, both quarks and the gluons being assigned a quantum number called color. Thank you.